Hey guys, what's up? Welcome to part 3 of this tutorial. This is the part where we talk about photons and global illumination. Now, global illumination per se, it's a term that I find ambiguous because what it really means is the bounce of light, and it so happens that you can achieve that effect with actual global illumination, but you can also achieve the same effect with final gather. So I find the term a little ambiguous in the sense of how it translated in as far as Maya, because I think both can do the same sort of effect, and together they would get the best effect out of global illumination. But just think of global illumination as indirect lighting, is the computation of indirect lighting, or the bounce of light. Okay. Anyway, excuse me. The third part of this tutorial, I'm just gonna use the scene that we had from the final gather render. We had a directional light which was casting ray trace shadows, and I had those shadows a little bit soft there, and we were using this walls which had a white Lambert. I'll take that digits back to 0.8, and we had a red object which was there. Alright, I'm actually going to change that. No, let's forget it. Let's just leave it like that. Okay, so when it comes to global illumination, just as final gather, the first thing you do is you need to load it up. If you go to indirect lighting or features, just as final gather, you will activate it. So you'll have global illumination there. Now there's a new thing called importance, but I'm not going to talk about those because I haven't read up on them. So, or radiance particles. So let's just call it global illumination for now. So once again, if you activate it, you can go to indirect lighting and you can change some of the settings. The accuracy is the same behavior as what we talked about in final gather. The scale would be a scale of the amount, so it will be more intense or less intense. And this radius is something that you can change once you have animation. If you increase the radius, if you keep it at 0, Maya will do it for you. If you change it, then you will change the radius of the global illumination photons. And then there's a distance for merge, which would be the same thing as like the interpolation. So you can think of this as the size of each one of those blotches, and this would be how much would they merge, and this is the total amount of blotches. So it'd be 500 blotches. If this was set to 1, then they would have a radius of 1, and if this was set to 2, then they would merge, they would interpolate from one to the other. So it's the same principle as the photons, but we're going to keep it at default. So again, once you activate it, this one's a two-part thing, because first you activate it in the render settings, then you go to your light and you go into the tab that's called mental array, and on there you have the option to emit photons. Now photon intensity is the amount of intensity of those photons, and the exponent is sort of like a value so that they are stronger or less strong. An exponent of 1 will give you more intensity, an exponent of 5 will give you a lot less intensity, and by default it's set to 2. And then you have the total amount of photons that this light will cast, which is now set by default to 10,000. First thing though about global illumination is it's the computation of indirect lighting. This light in this case, which is not something we're going to use anyway because it's a directional light, I'll talk about that in a second. This light is casting, in this case, indirect lighting because of the photons, and it's also casting direct lighting, which is the diffuse particularly. So it's a good idea to have two lights, one that will cast your direct illumination and another one that will cast your photons. Now photons are expensive, and I personally would tell you to stay away from directional lights. I'm going to keep the renders there at default. Let's see, make sure, yeah. And I'm going to go ahead and make a render. See how that looks? It's really blown out. And then you can say, well, if this is the intensity, I'll make it less. That might still be too much. Okay, so I'll make it really a lot less. Okay, that's a little bit too less. Let's make it 10. See if I can show you what's. You can barely see it, but you can still see some of the issues that happen. Okay, so you can see the blotches there. But once it's done correctly, it, at least with prior versions of Maya 2009, because I haven't tested this out in 2009, you would get some brighter edges in some areas. I don't know. Let's try it. Let's increase the amount from 10,000 to 100,000. So we're gonna get a lot softer. And as you can see automatically though, this is computing the bounce of light. There's the direct light source, and that's all the bounce of this light. If I take off the emit diffuse though, all we're gonna get is the indirect lighting. So it's just the bounce of the light, of the total amount of light that hits the surface. Oh, cool. Well, you can see a little bit there. I don't know if you can see that this little corner right there is actually a little bit brighter than everything around it. Now I'm nitpicking it here, but I know it happens once you have more complex scenes. You can also see it here as well. With direction lights, if you were to use photons, you would want to give your objects some thickness, like that at least. Or let me take off the keep faces together, just re-extrude it, and that way, sort of like the photons that come here, they're gonna stay there because of the normals, and then the ones that come in here are gonna stay in this area because of the normals. However, I'm just gonna keep that there just because it's good practice with photons to have thickness. However, directional light, since it's thought of as infinite light in space, then what happens with that is that there's going to be light rays coming from here, 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 all over. So you can think, I mean, Maya does try its best, or mental ray tries its best to focus the photons only on the area where there's geometry, right? But you know, if for any reason you had like an actual environment, then it's going to base it off of that. So if you wanted to have quality on this area, and you're still going to get light here, 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 then, you know, 10,000 photons, or let's say 100,000 photons, would give you an overall quality, but not an amount of quality just here. So if you wanted to have better quality here, you would have to increase the overall quality all over this area. So instead of having 100,000 photons, you might end up having 100 million photons. I don't know, a lot. So rather than using a directional light for photons, it's better to use something that can localize the photon emission. And that's why, at least in my case, I like to use spotlights, since they're quick to render and they have that cone, which means that the photons are going to be condensed on whatever the cone angle is set to. And that's also the reason why I'm saying you can have two lights rather than one, because you can have this one, I'm going to call this photon light, and then you can have another light source which would take care of your direct light. So you can have another light, I'm just going to make it and then hide it, which would give you the overall direction of the light, and I'm going to call this direct light. I'm going to add this guy to a layer there. I'm going to call this layer 3 direct, and this guy I'm going to call, okay, there we go, it's assigned to layer 2, but I'm going to call it layer 2 photon light, or the bounced, the one that makes the computer or Maya think about the bounce of light. So let's hide the direct for now, or let's hide the photon light. Yeah, let's hide the photon light and show only the direct light. So in that case, you would want first to get the correct direction of the shading. So I'm gonna make sure I take off the illumination off for a second, and there's only direct lighting being computed here. And of course that light will need some shadows so that it actually looks like there are shadows on the scene. So you can see that's the light source, and that is where the shadows are coming from. I'm gonna make it, yeah, probably like there, I would say is a good idea. A little bit more so it actually hits our surface. There we go. So you can see that the light is hitting the surface. Now again, back to bounce light. If you had a light ray that's coming from here, then that would hit this red object, and therefore some of the surfaces down here would get some of that red, and then some of that might bounce out into other areas, and even some of that direct light will bounce into other areas, and therefore will create some shading here that would be white, and then some shading here that would be red, and so on and so forth. Direct light is not going to do that. So once you got your direct light working, you can hide it. Now let's show the photon light. Now the first thing we would have to do, because it's a spot and this is supposed to be the sun, then you want to keep this spot first of all in the same direction as the direct lighting, so it actually makes sense. And second, you would want it to be really far away, like the sun, because if it's closer, the shadows would kind of like stretch out because of the angle. Let me go back to my perspective so that I can explain what I'm talking about. You know, if this was the case, right, and if you look at this cone, it's got this, and that would be the other angle. Now, once here, because of the position, then some shadows are going to be like from here, and they're probably going to stretch like all the way to there. But if on the contrary, this light was way out there, like the sun would be, and its cone angle of course would be a lot smaller, then the shadow, instead of like going from here to there, is gonna end up going from, let's say, from here to here. It's gonna be more localized and more focused, which I think makes more sense. That's one of the reasons why I think it makes more sense. There's another reason though. As we've already talked about, the light has quadratic decay. It decays over time. Now I know that the sun comes from like really far away, so the amount of decay that you see here is not so important. But as far as photons go, photons are not based off an infinite point in space in this case. They're just focused on where this particular spotlight is. So before you start making a whole bunch of renders with photons, it's better to make sure that this light would have enough intensity to shine on this object. Now if it's set to no decay, then it's not, photons automatically have quadratic decay or low illumination, so we're going to change this to quadratic, and therefore you'll find out right away. Just going to make sure that this is emitting diffuse for a second. You'll find out right away that there's not enough intensity. So I'm going to increase the intensity to 9,000. I'm getting some bounce. I'll increase it to 30,000. There's we go. So it's a little brighter as far as the direct light goes. I'm gonna go with 80,000. Now it's like nice and intense, like the sun would be. So 80,000 is our intensity with quadratic decay. The reason why I'm talking about that is because once we go into the render settings and we activate our global illumination, and we go into the light itself, tell it not to emit diffuse, and tell it for now not to emit any photons. I'm just going to make sure under mental ray that there's no photons for a second. we make a render, it should be black, because that's the idea. This is a photon light, so photons have nothing to do with this intensity values. The reason why we changed this to 80,000 was to actually figure out under the photons what will be the photon intensity that we'll be putting. Because if it's 10, for one, it's taken a long time to render, and I'll get into that in a second. But second, everything is black still. So that's why we changed those values, so that we can change the intensity to the same intensity that we have there, which was again 80,000. So I'm going to give this an intensity of 80,000. Now before you make a render though, you want to make sure that your photons are localized where you need them to be localized. That way it would render faster. I'm just going to look through selected and see how big this cone angle is. That means that it's emitting all the photons throughout that whole area. You take your cone angle and make it smaller, and this will be 3, so it's really focused just where you need it. Make it 3.5, because we only need it where the light is coming through on that window. Then your renders will be a little bit quicker as far as photons go. So let's give it 80,000 photons, really localized, and make a render. And it's still a little bit too dark. Take that exponent back down to 1. We're going to brighten up, like so. So you can keep the exponent at 2 and then make this twice the amount, which would be 160. Great. So I'm going to give it 1.8. Okay, so it's not 160, it would be 64,000 or 640,000. Let's go 640,000, see what happens. Yep, there we're getting a little bit of that light there. Because it's an exponent of 2, so it would be 8 times 8. Or 80,000 times 80,000. I'm bad with math. It's probably going to be higher than that. I'm just going to take it up to 2 million. So we got 2 million photon intensity. Yay! So now we're getting a little bit of bounce there. I'm going to make it 60,000. Or 60 million. Or 6 million, sorry. Okay, there we go. So we have the amount of intensity that we want. You can always have it with less and decrease the exponent, but that's personal. Now the reason why it looks right now, it's not such a bad quality, but if you want to have better quality, then you can change the global illumination photons from 10,000 to, or is this, it's set to 100,000. If it's set to 10,000, it would look like that. Now I have 100,000 photons on that area. It's going to look softer, like that. See? And if to that then we add our direct light, then one is going to give us like the computation of the bounce, and the other one is going to give us the idea of the direct light source. So you can see how they kind of like play together. Now I'm not saying that that's the only way. Like I said, you can always tell this light to emit, diffuse, and change its intensity, because that at the end is not going to affect the photon intensity. But I personally find that it's better practice just to set your photons to the intensity that you need to get the effect that you want, and then have another light source that would focus on the direct lighting. So let me just select that direct light. I'm going to soften up those shadows a little bit. Let's make it 2. And then you are getting direct lighting, indirect lighting, or the bounce of light. And if you want it to look better, it will just be a matter of increasing either the accuracy or increasing the photon light amount of photons. So I'm going to go from 100,000 to 900,000. So you can see that it's expensive to render, but the results end up, turning better and nicer and better every time. Furthermore, if you, and this would be like, that would be pretty much it as far as photons go. I mean, they're pretty simple. It's just that, like I said, it's based on the actual light source. You can change the color of the photons if you want, so that, like they're a little bit more yellowish, more like daylightish, or even more bluish if it's more like a general tone that's coming in. And then if you to this add, I'm just gonna show my window here, which I'm gonna make white. See how that looks right now by default. You can see that it's now taking a long time to render. We'll change this material to a Lambert for a second here. So you can see it's thinking, and it's going to take a little bit of time because when I show the window, the photons are sort of like blocked by that window, even though it's not casting shadows. So what we're gonna end up getting here is, I think, black. I mean, except for the direct lighting, there's really not going to be any bounce of light inside of it, but let's take a look and see what happens. And if you want me to, I'll pause. Well, it's almost there, so let's just give it a second and listen to some Enya while we're at it. Enya is cool. It's relaxing. Okay, so render's done, and see what's happening because I have that object there, and you can see a little bit of like it's trying to bounce it off inside of the object, but as far as whatever's inside, there's nothing. So this case, what I'm going to do is I'm actually going to hide that window for a second. If it was transparent though, and you had caustics on, then you would see the caustic effect and the shadows and all that stuff. But however, I'm going to hide it on for a second. I'm just going to change the camera's background to white, because if you change the camera's background environment, then Final Gather will read that background, and then that's what we had. And then we're not gonna increase render times, we're actually gonna keep it pretty much the same, but we'll have Final Gather, and we will also, I think I activated it, I'm not sure if I did. Yep, there we go. So now it's computing the Final Gather points of the white environment of this camera, so everything that's out there, and it's also going to compute the direct lighting, which is the directional light, and it's also going to compute the photons hitting this and giving you bounce, and on top of that is going to make an extra computation of Final Gather of all the lighting that's happening inside of here and the materials that are assigned. So of course the render will be a little bit higher or a little bit more expensive as far as render times, but the result will be a little bit better. So again, let's listen to some Enya while we wait. I rather put Enya and wait than pause the tutorial, so that you can know how render times actually, how long it actually takes to render. Usually I go for cigarette this time, but this gives you a realistic approach as far as how expensive it would be to make a render that has low illumination and final gather all together on a very simple scene. That's why the idea is to try and cheat as much as possible. While this render finishes, I'll mention one thing. In a later tutorial, I'll talk about image-based lighting, which is sort of like the dome idea, but it's like embedded within mental array. So the computation of final gather and glow illumination would be a little bit faster in a scene like this one. Just because of the fact that me, instead of changing the environment color of the camera, it'll actually make a dome that's not geometry, so it'll render quick, and it will allow the photons to go through and all that stuff. So usually that's the best approach, is to use that IBL node. But again, I'll talk about that in a separate tutorial. So anyway, there you go. That's how it used to be. It took 14 seconds. And this is how it looks now. This is still draft settings, by the way. This is how it looks now with global illumination and final gather on, which went from 14 seconds to 2 minutes and 48 seconds. So just to put this in a little bit of perspective, it took, so 2 minutes 48 would be 60, 120, 130, 140, 150, 168. So it took 160. I'll put this in perspective. This render equals 168 hours. The other render took 16 hours. Alright, so I mean, I know it was seconds, but I hope this puts it in perspective of how expensive this can be. You can get to this, and this is a really simple scene. I know it hasn't been tweaked or anything. You can increase this render times a good amount, but just to give you an overview, with just the photons, only photons equals 16 hours, or half a day. Just barely. Photons plus final gather equals 168 hours, which is, I don't know, you figure it out. It's a lot of days. There we go. So happy rendering. Alright guys, so I'll be seeing you with the next tutorial, and yeah, just remember, play with things, and you can increase all these render times, and you can make things look even better than my sucky renders. But that's pretty much it. Alright, talk to you, bye.